In this class, we're going to look at ANOVA. This is another one of those very common, very popular, very easily encountered tests that you want to know something about. It is probably also a word that you have seen before by going through some research articles, although you may have wondered if it is a word, right? For one thing, it's always spelled all in capitals. Secondly, we've probably never heard of it before in English language and so on. So we're going to look at the issue of what ANOVA stands for, what it means, but more importantly, we're going to look at what this test actually does, when to use it and when not to use it. Now remember that for the t-test we notice that it works only when we have one or two samples. So when we are actually either testing one population or comparing two populations. So we may be asking a question about the mean amount of time that astronauts can be in space, or the mean amount of time that astronauts can be working without getting tired, or we may compare something about astronauts to a similar thing about actors, say. But what if we have three or more groups to compare? So what if we want to compare the amount of money, for instance, that astronauts make as opposed to actors or to singers or to business people or to Boy Scouts? Now, if you have this question in mind, how do I compare three or more groups? One obvious option available is, why not we compare them two at a time? So why don't we compare astronauts to actors and actors to business people and business people to Boy Scouts and so on and so on. Well, the reason why it's not a good idea to do this, although in general, because in some situations it can be useful, is that of course by doing this we're going to end up having to do several tests. And you may remember that once you start doing several tests, the probability of a type 1 or a type 2 error goes up. The more tests you do, the more the probability that one of them will be wrong. So statisticians decided that it was a good idea to try and have a single test that would compare at the same time several groups. Now, the other option that one might think of is, well, why don't we adjust the formula for the t-test or the procedure for the t-test so that it works for three or more tests? Well, unfortunately, that formula does not generalize. That formula, the procedure for a t-test, is structured in such a way that it only works when you're comparing one group to a fixed number or two groups. Okay? So what we need is a totally different approach. As usual, I'm not going to go through the number crunching aspects of this different approach given by ANOVA, but I'm going to try and give you a little bit of an idea, a little bit of the flavor of how it works.